Okay, so a spy uses a telescope to track a rocket launched vertically from the launching pad 6 kilometers away. At a certain moment, the angle between the telescope and the ground is equal to pi over 3 and is changing at a rate of 0.9 radians per minute. What is the rocket's velocity at that moment? So the ultimate thing we're looking for is the rocket's velocity. So they gave me a nice little picture. If they didn't give me one, I'd have to draw it, but they gave it to me. So if I'm looking for velocity, I'm looking for a rate. In this case, I'm looking for a rate of y. So my ultimate goal here is to find dy over dt. Ultimate goal. They tell me some different things. They tell me 6 kilometers away. I already got that marked. The angle theta is equal to pi over 3. So I can go ahead and say theta equals pi over 3 and is changing at this rate. So the change in theta over time equals 0.9. Wonderful. Once I've got that all set up, I need to look for a formula. This is a little bit tougher problem, and the key to this problem is understanding formulas. They have told me theta. They have told me 6. And I'm ultimately trying to use that to find y. It's a right triangle because I'm measuring height. And the thing you have to recognize here is I've got an angle on 2 sides. So we're going back to SohCahToa from trig. This y side compared to theta is the opposite side. And this 6 compared to theta, the 6 compared to theta is the adjacent side. So I'm looking for a trig function that deals with opposite and adjacent. It's tangent. So the formula I'm going to use here is tangent of theta is going to be equal to the opposite y over my adjacent, which is a constant of 6. The distance between the spy and the rocket is never changing. So using this information, I could plug in pi over 3, but it's changing, and I could use that to solve for y. We did that in class, but it's not something that we necessarily have to do, and we'll show you why here in a second. So if this is my formula, I am then going to figure out the change of that formula. And so let's go ahead and do that. Tangent. I'm just going to rewrite it first. Tangent of theta equals y over 6. Now we're going to take some derivatives. So the derivative of tangent is secant squared. Derivative of theta, so it's secant squared. I rewrite the baby times the derivative of the baby, the derivative of the inside, d theta over dt is equal to y over 6 is weird. And so if you look at y over 6, you'll screw that up. Instead of writing it as y over 6, I'm going to write it as 1/6 y. The exact same thing, but by writing it like that, I just have better success. So derivative of 1/6 y is 1/6. Derivative of y is dy dt. Plug in what I know. Secant squared theta is pi over 3. D theta dt is 0.9. 1/6 dy dt, and that's what I'm looking for in the end. My ultimate job is to find dy dt. Oops. You lied to me. Give me the other color. So to solve this, I need to figure out the thing that's going to screw us up the most is this secant squared pi over 3. So in my calculator, I don't have a secant button. First of all, I want to make sure I'm in radians, but I don't have a secant button. So instead, I'm going to go 1 over cosine, because that's what secant is. Secant is the reciprocal of cosine. 1 over cosine of pi over 3. Type that in, I get 2, but that's not what I want. I want secant squared, so I'm going to take that and square it. So 2 squared is obviously 4 times 0.9. I'm going to rewrite that without using a highlighter. So 4 times 0.9, that's going to get me 3.6. And the last thing I need to do is divide by 6. So I'm going to take 3.6 divided by 1/6, or another way of saying divided by 1/6 is saying multiplied by 6. That's my final answer. 21.6 is what dy dt is. And that is measured in the change in y, and y is kilometers. And my time is, what's my time? Time is minutes. 21.6 kilometers per minute is my final answer there. Again, not too bad. The trickiest part there was understanding, hey, I've got a right triangle, and I've got an angle on the opposite adjacent, so that's why I used tangent. Plugged in the constant, which was 6, took the derivative, and solved. Hope that helped.